Hey, good afternoon, everybody. This is Mark with Rainmakers Customs. Hey, I've been seeing this life hack or electronic hack for some time, and I finally decided to go ahead and give it a try, just because of the fact that I thought it had some merit. Well, unfortunately, I can't uh, give credit where credit's due because I'm not the first one to come up with this. Um, it's actually, I've used all the different components and I've used them in many different variations, but not this particular one, which is parts testing. So, like I said, I'd seen at least a dozen different variations of this, some using transformers, some of them plug into the wall, using all kinds of variations of different formats. And I thought, I'm going to go ahead and try to build one myself and see if there's any merit to it, see if it actually works, what have you. So I went down and ordered, actually I keep a couple of these on hand, just a regular project box. So I got me a project box, pulled the other components out of my inventory. I ordered a buck boost converter. This one is a step up, not a step down, because they are available in both configurations. So this one is a step up. So we're running this all on a 9-volt battery, and I decided where everybody's got their own take on it. I went ahead and wanted to do something a little bit different because I go back and forth with all different types of equipment. So I thought, all right. So what I did was I went ahead and I put in a couple of jacks here that I usually keep stuff like this on hand for different builds. So I put little jacks in there so that I can actually plug in my test leads. So I can actually plug my test leads in and go from there as far as checking out different pieces of equipment. Just like your regular multimeter. So that's what I did here. And we'll get that actually soldered in here in just a few minutes. So one of the things that I ran into, and I actually used, because it seemed like everybody was using the same value, well, I ran into some issues. They call for a 2.2K and a 3.3K in almost all the videos that I've found. Well, I found an issue with that when I went through and started checking components. So these two values here, I actually changed based off of the voltmeter that I've got here, and I've seen everybody use multiple different variations, but they're still using the same combination here. So, they used a 2.2 and a 3.3. I changed and I went to a 1.5K half watt and a 2.2K 1 watt in order to go ahead and make everything stable. So before that, I actually added a small capacitor, which did seem to actually help as far as with the stabilization. It's just a little 100 microfarad at 35 volts, and it's going across the positive point of our rectifier bridge and our negative point. Then we've got our two leads here, which are for the AC. In this case, we're actually running DC into it, but it'll go through the rectifier bridge and comes out. No matter which way you flip these leads here, it doesn't matter since it's classified as AC coming in, even though we're using a buck boost converter and it's DC. So we've got our DC coming in, quote unquote AC. Then we go through our rectifier bridge. We've got our common ground and our positive out. So on the voltage out here, we've got the one leg that's actually coming off of the 1.5 that's actually turning on the voltmeter. So the 1.5K goes to the red lead, which actually just turns it on. The yellow wire is the voltage sense. So we've got the yellow wire on the outgoing side that we're going to use to test the components. We've got our negative lead, comes off of the negative side here, and this is going to be our negative side for testing. This will be our positive side for testing. So let's go ahead and check a couple different components. I've laid a few of them out. Like I said, I've played around with this a little bit, but we'll go ahead and get this finished up, and we'll show you what what we come up with. So let's turn this on. And I set the voltage, resting voltage, at 28 volts. A little more straight down on it here. And we're going to grab an LED. I have no idea what color these are because they're all crystal clear. So before I soldered in here, I wanted to show you guys what we're looking at. So okay, this one's a white LED, and it's showing 2.92 volts. So, and that's actually pretty accurate, 9.2. So 2.9, we can call it a 3 volt LED. I just grabbed 3 different colors out of there. This one's red. Red usually is one of the lowest voltages, and it is 2 volts. It means this one's blue. And we've got 2.95, so this one's also a 3 volt diode. But it works on many different kind of components. We've got some Zener diodes. Now granted, I know what these are, and that's great because that way we can actually kind of confirm what it is. But if you didn't know what it was, it's a great tool to know whether or not you're dealing with a Zener diode or not. We've got 14.2, shows up there. I've got some 5.6 here that's out of the package. Showing 5.9, again 5.6 or 6 volts. So, there's a little inaccuracy with it, which I could tweak the meter and we could come up with the exact value, but one of the things that I will caution you is if you set it based on a 5.6, your 14 volts is going to be off and vice versa. So that's another reason why I changed and went to the different values here, because I had the most consistency and the meter didn't do any kind of flaky movement. So let's grab 1 or 2 other little components here real quick. And if they're bad, it'll also show you that it's bad. So I thought that was kind of neat as well. What have I got here? There we go. So, and you can also test the different LEDs to find out what color they are. And it doesn't matter. It's going to tell you what the voltage is so that you can kind of get a reference for what resistor to use. Okay, there, it's not lighting up, which means I've got it backwards. 2 volts. So the yellow one's got 2 volts. This is supposed to be 3.6 volt Zener. And we got 3.2. Okay. Let's check one of these out here. Since they are a different color. Just because I ordered them and they came in listed as that doesn't always mean that they are always perfectly the same. For 4.0. So there again depends on your current drain on the diode, but we know that it is between 3.6 and 4 volts. These back here say they're 4.3. I don't think I've used any of 4.3s in probably 15 years. So that's the reason why I keep them in a little baggie, so that I know that they can't get interchanged or intermixed. Okay, 4.3, and this is 4.5. So fairly accurate. So it's not going to be a perfect match on everything that you do, but it definitely gives you a good ballpark of what you're working with, and where you can test to find out if the components are good or bad. So, all right, guys. Hopefully somebody found this interesting and a little entertaining. But if you guys have come across this little hack, please hit the like and subscribe. And like I said, we'll try to do some more fun stuff like this. But definitely fun, definitely worth using just for quick references, especially if you're just beginning into the hobby. This is a great little device and a great little tool to kind of give you a good idea of what's going on. Like I said, you can check diodes of all different variations. A few other different components that I've seen that a few people have done as well. So, yeah, like I said, quite interesting. All right, guys, I'm going to get out of here. We're going to go ahead and solder in our two little pieces here. I'll mount this up, and I'll probably do another follow-up video a little bit later on with this. So, all right, guys, take care. Don't forget to hit the like and subscribe, and we'll see you on the next video.